just as a quick brief introduction, this is sort of our third focused review meeting where we're seeking approval of the KEP, get it merged, get to the opportunity to use the official repos for the prototyping and future code. The KEP is big and it's long. It's difficult to go through it all in a meeting. There were some great points brought up at the previous review which have been addressed and should be visible in the current version of the KEP. And Sid came up with the idea that maybe a simple focus slide deck that summarizes the KEP will make it easier to digest and get through. With 5 to 10 minutes left at the end of the meeting, we're striving to get to the point where we could do a vote, at least a straw man vote, see where people are leaning toward how close they are to approval. All right, Sid, are you? You've been made a co-host.
Just before we go on, may I suggest that if we are going to put together some sort of material to help people understand at a high level the KEP and the associated functionality, that it be grounded in the core use scenarios that are talked about at the beginning of the KEP?
That's exactly how it's done. I mean, that's exactly how I've done it today. I'm glad you actually brought that up because that was my intention behind making these slides. Main thing is, I think in order to give a high level complete picture of what this proposal is doing from the perspective of one, the user that's going to consume it, and two, the vendor that's going to write the driver for it. One of the things I felt like it was hard to cover last time was the gRPC spec, which is the contract between the vendor and Kubernetes bucket APIs. So let me start by sharing my screen.
Are we recording, Xing?
Yeah, recording seems.
I have started recording. Yes.
Thank you.
No problem.
Okay. So I'm going to start out this slide deck really in a basic way. Quickly, we'll jump into the details. I've taken, for explaining some of the workflows, I've taken the simplest successful use case and gone forward at that. You'll see it shortly. So we're defining a new standard. I'm starting with the absolute basics, just like the definition for anyone that wasn't a part of this all these months, just so we clearly explain what we're doing. It's a standard for consuming object storage in Kubernetes. It's basically like CSI is a standard for file and blocks. We're creating a new one for object storage. We're calling it Container Object Storage Interface, COSI or COSI. Yeah, and just to reiterate what object storage is, I'm sure we all know what this is. It stores data as immutable blobs within organized into buckets. And bucket here is going to be a primary unit of management. In our system that we are building, we provision, deprovision, grant access all at the bucket level. Now, we are going to do it across multiple object storage vendors in a vendor agnostic fashion. And let's get into what these 4 things mean: provision, grant, revoke, and deprovision. So let's start with provisioning. Provisioning is basically creating a bucket and providing it to, just creating a bucket or checking that the bucket exists in the backend. So what's the backend here? Okay. So we've defined 3 separate components here. The one on the left is the user or admin. The middle is the COSI, which is our system. And third is the backend, which is the cloud or the object storage provider that actually creates the bucket. The workflow is user or admin creates a bucket or requests a bucket to be created, and the system understands this request somehow and then communicates with the backend to provision this bucket. So let's look at what the contract between the user and the user or admin and COSI. So we've we've created so one second. So Cozy runs within Kubernetes, and the declarative standard way of communicating with Kubernetes is through the objects, Kubernetes objects. And we've created, in order to model how user admin requests a bucket, we've created a bucket request resource. Now, this resource has fields required to request a bucket in the backend. As a name, it belongs to a certain namespace, whichever the user is originating the request from, or a namespace the user has access to. A protocol which says what kind of object storage protocol do I expect. About bucket prefix, some form of prefix to say this is how I want the bucket name to start, and then a bucket class name. I've created a dummy kind of use case where the name of the bucket or the name of this request is something called profile pictures under the namespace profiles, and the bucket class name is write once read many, to explain a scenario where you create profile pictures, you read them many times, you don't delete them though. So here we showed that there's a bucket class name. Bucket class groups a bunch of bucket requests based on certain parameters. In this, okay, in a bucket class, we have a provisioner set, which is the actual vendor specific code that will go and create the bucket in the backend. Again, protocol is set here, which tells you what kind of protocol we expect the bucket to serve. Then we have something called as the anonymous access mode, which sets the access policy on the bucket itself. A bucket can be either a public bucket, so everyone can read and write, or a read-only bucket, self-explanatory, read-write, or private, where by default, nobody gets access to it unless access is explicitly granted to it. A release policy says what should be done with the data in the bucket after this bucket is deleted from Kubernetes, not the backend, just Kubernetes. Allowed namespaces is the list of namespaces, Kubernetes namespaces, we want this bucket to be provided to. So when requesting the bucket, so say if in this example, profile picture bucket would ideally only be relevant in this made up scenario. Say it's only relevant for teams that work with profiles. And let's say they use a namespace called profiles. And so we've set the allowed namespaces to this.
Quick question on that. Why is the UID there?
So we've, all these weeks, this was something I had as a question. We were worried about the scenario where someone deletes a namespace and then creates another one by the same name.
Yeah, I think in that case, we wanted to apply by name, not necessarily the specific instance.
I was, I thought the same as well. I'm explaining it exactly as we've put in the cap. One of the reasons being I came in kind of midway, so but I completely agree with you. It should be just the name, and if someone does do that, where they delete the namespace and bring it back in,
So,
it should apply to the new one.
so Saad, and we got feedback from Nicholas on this too. Thanks, Nicholas. Saad, what you're saying then is really it's the string of characters, the name that matters, not an instance of a namespace.
Right. In general, that's what we care about in Kubernetes. There's very few cases where we actually care about the UID.
Okay.
Where we care about the UID is things like the persistent volume claim and persistent volume objects, where the specific instance actually matters. But outside of that, it's generally the name.
That's great. I mean, it simplifies it, makes it easy. So we will include that suggestion.
Cool.
Yeah.
Thank you.
Absolutely. Then we have
sorry, I had one question. So in general in Kubernetes, there's a concept of Kubernetes admin creating a namespace and assigning some kind of a storage quota and stuff like that. So how can a storage quota be limited for objects created using this object class? Is there any quota management going on here?
As
out
of
of
right
scope
now,
right now.
no. So someone answering, please go ahead.
I was just saying that's out of scope right now, but that could be an enhancement at some point in the future.
Yep.
Okay.
Yeah.
So parameters here is a generic map string structure that lets cloud provider or vendor specific parameters to be passed in. In this case, I've just set the region. However, like if you look at GCS, there's a project ID, or Azure has a project ID and another container name. Each cloud provider has its own set of parameters that's modeled in this structure. Going forward.
Apologies for, can we just go back to that? Yes, thank you. Can we get a clarification on what the purpose of the UID is, please?
Oh, we're going to remove the UID. That was the discussion we just had a second ago.
So there will not be any UID on any of these bucket requests?
Bucket class,
Bucket
yes.
classes?
Yes. The original intention was here that we have a list of allowed namespaces. The idea was only the namespaces that we've deemed as safe for safe for providing access to this bucket or these classes of buckets should be allowed to do them. Should be allowed to access them. However, our concern was if we set the allowed namespaces to a bunch of namespaces and someone goes ahead and deletes those and recreates a new one with new credentials, they shouldn't be allowed access to these buckets. However, that's non-idiomatic to Kubernetes. So we're going to go ahead and remove it.
Yeah, and just so everyone's clear, what this is stating is any namespace with the name matching what's specified in the bucket class can gain access to the stored object storage credentials.
Yeah.
Yeah.
Okay, and the namespace can have multiple labels as part of the metadata, correct?
We're not, yes, that is correct. However, in this case, we're not selecting a namespace by labels. We're specifying the names directly.
Okay.
Explicit.
I think that should be documented.
Yeah, okay.
What's confusing there, John?
Just the whether or not the bucket class could be tied to a namespace.
Yeah, I think we can correct that in the documentation for sure. We can add a statement clearly saying how we're going to represent this. We're going to move forward with this.
Thank you for your patience, sir.
Oh, absolutely, no worries. So earlier we saw how the user or admin communicates with Cozy. Once the bucket request and bucket class are provided to the system, Cozy goes ahead and processes it before translating it to a request that the backend understands. And what it does is it takes the bucket request object. I've just put the relevant fields here. And then it takes the bucket class object. Again, put the relevant fields here. Basically all the fields under spec for both of them. And I've marked the bucket class fields with orange and bucket requests in green. And my mouse scroll bar is super sensitive. And I don't know how to fix it. It's the Apple Magic Mouse. So I'm just going to go ahead with this. The bucket object is created by the system. This bucket object has the orange set of fields from the bucket class, and then the other set of fields from the bucket request, or they're auto-generated. So the provisioner is from the bucket request. The release policy is from bucket class. Anonymous access mode, bucket class again. There's a bindings field. We'll get into it in a few slides. Allowed namespaces, remove the UID. Parameters comes from the bucket class. And the protocol structure generates a bucket name based on the prefix that's provided and adds a UID to it. And then when it first gets created, the status of the bucket it's not available.
And the intent of the prefix is that if 2 bucket requests come in using the same bucket prefix, they'll both be assigned globally unique names, at least in the context of this. Is that correct?
Yes.
One minor optimization we might want to make is on the status. I know we talked about using conditions, but instead of conditions, we may want to just use Boolean values here, things like bucket ready, and then you could add additional Booleans in the future for any other kind of binary state that you want to add, as long as it doesn't invalidate the previous state.
Yeah, I think Shing also mentioned it, and I think that makes sense. We just went ahead with the usual way of doing things with the conditions. However, there's no reason why we couldn't do the direct.
Yeah, that's fine. I think we could fine tune that in API review. It's not a huge deal right now.
Got it.
I'd like to call out, just for people looking at the official KEP, that under conditions, the reasons that have been stated are not actually what we were thinking of doing. And then if we eliminate conditions altogether, it's mute. I just wanted you to know that those reasons were a first pass and not what we actually think right now makes sense.
Yeah, I'll go over them, Jeff.
Okay, thanks.
Few slides. Yeah. All right. So we saw what Cozy did. So it takes the bucket request and the bucket class and creates a bucket object. Now then the bucket object is passed along to the vendor side of the backend, or vendor side of the system, where we use a gRPC protocol. The gRPC protocol defines a contract between Cozy and the vendor library, the vendor driver, or the provisioner. And here's what the protocol looks like. And these are the fields that driver requires to go ahead and create a bucket in the backend. So it needs a bucket name, needs a bucket context. For different cloud providers, we have a different set of options that need to be passed in. Say, for instance, project ID in Azure. That's captured in this bucket context. And then the anonymous access mode, which is access control set on the entire bucket. And we have
and the map string is in essence saying you have one or more key values where the key is a string and the value is a string.
Yeah.
Is bucket context here mapped to the parameters from the class?
Yes.
Okay. Could we consider renaming this to parameters to match that?
Yeah, absolutely. I think that's not that's definitely possible.
Cool.
You can do that. Yeah. Hey, is Srini or Jeff taking notes on these suggestions? If you could do that, that would be great.
Yeah, we have Aaron and Srini taking notes.
Okay,
I think we're
thank
good.
you. So the fields for filling in these fields for the example we just showed, the bucket name is the auto-generated one, profile pics dash UUID. Bucket context, parameters, region US East 1. And then the anonymous bucket access mode set to private, which is what we wanted in the bucket object.
And at this point, the dispatching is already determined that, for example, it's going to an AWS S3 provider?
Yes. So that is decided based on the provisioner that is set.
Yep. Yeah. So the invoking of the correct provider, provisioner specifically, would happen at the earlier stage, and the correct fields would then be passed down.
Yes.
And what happens if a provisioner, a backend, can't be found that maps?
Then the bucket object remains in bucket available set to false indefinitely.
And it will keep trying until such time as the backend comes into existence?
Yeah, backend that advertises the specific provisioner comes into existence, yes.
Okay, good.
And the response, if everything is successful, is an empty response. If there is an error, there's a separate error channel in gRPC along which an error would be passed. I'm going to go ahead without going into the errors, since I'm only explaining the easiest, simplest, successful case here. We will get into the errors as the second step of this presentation. But for now, I'm going to move forward with the provisioning. So once that successful response is returned by the vendor provisioner back to the COSI system, we go ahead and set the bucket available to true on the bucket object, indicating that the bucket has been provisioned in the backend. And then what we do is percolate that back up to the user by setting bucket available to true in the bucket request object.
Okay, so the that single successful indication going back, that's kind of implicitly synchronous in the gRPC protocol.
It's how do you mean? The gRPC protocol simply just informs that it's done, and then there is an asynchronous set of steps that leads to this.
Okay, so that was the question that I had. If my provisioner takes 10 minutes to set everything up, will the gRPC call just be left open for 10 minutes, or will the gRPC call return immediately? And then there's some other indication, some asynchronous indication that then triggers the bucket available being changed to status true.
Oh, that way. So the gRPC request has a timeout. So let's assume that the timeout expires, how much ever time it takes to create the bucket is longer than the timeout. Then an error status is returned, and a bucket available is continues to be false. But then we keep retrying. So when error status occurs, we push the request to the back of the queue, and the queue of requests that need to be served. And when it gets re-triggered again, say the bucket is created at that point, we get back the error response saying already exists. And
so
at that point,
that pattern's fine, with one caveat. The provider needs to be able to determine whether a subsequent request is exactly the same as an earlier request it's still working on.
Yeah, so that's done using the bucket name.
Yep, which is guaranteed unique for each bucket request.
I think somewhere in the spec, you just need to say that all the gRPC calls for COSI need to be idempotent.
Yeah.
And we have to be specific about which fields must, or can be depended on for idempotency.
Yeah.
Yeah.
I think this is pretty straightforward for that, but I agree that that needs to be documented.
Yeah, and David, it's a good point you brought it, because the bucket name can be the same for different requests. There could be a green field request and right behind it a brown field request, and they're both the same bucket name, right? And they're trying to do green to brown, and so a driver could get the same bucket name. Provisioning the bucket foo takes a long time. You could get foo coming back again, but this time it's a brown field request to foo, right?
Yeah.
So we do have to handle that.
Yeah, it's item. Yeah, we will document that. So yeah, at this point is where provisioning ends. Provisioning is strictly creating the bucket alone, in case it doesn't exist, and that's the simple use case I've shown here. And at this point, provisioning ends, and any application or any user that wants to consume this bucket has to first request for access to this, which is the second workflow, the grant access workflow. I can hear someone's background noise. Okay, so the grant access workflow. So in this, for this workflow, there's an additional component, which is the application that's going to consume this bucket once it's granted access. So just shown in the arrows here, the user talks to COSI to request access for an application. COSI talks to the backend, gets the access, and then from the backend, it takes the credentials and gives it to the application. The application can then use the credentials to make object requests of different sorts.
So did we cover where the credentials get passed from the backend to Cozy?
That's going to be covered in like the next few slides.
Got it.
So just like when requesting a bucket, when requesting an access, we've used the object resource type bucket access request. Bucket access request is a namespace resource which resides whichever user requests the bucket access gets, creates this object in their namespace. They specify the name of a bucket request in order to point this access request to a particular bucket, and access types can be grouped into a class, and that's captured in the bucket access class, and
So
it's referenced.
this is a green field or brown field or both?
So this would be for greenfield, definitely. For brownfield, if we're doing static provisioning, then we wouldn't need this. But if you're doing dynamic provisioning, the greenfield, the brownfield case, we would.
Okay, so how do we map from the profile pics name specified here to the profile pics hyphen something auto-generated earlier?
The bucket name, you mean?
Yeah.
Yeah, so the bucket request, I think I did not capture this, but once the bucket is provisioned, let me go back. So, oh yeah, so the bucket request has I've not captured this here. So bucket request has a bucket instance name or a bucket name in the KEP. We'll get into it, and that is a pointer from the bucket request to the bucket. So the name for the
So we have a single layer of abstraction. The bucket name is a protocol specific construct. With respect to the Kubernetes environment, you wouldn't ever refer to bucket name directly. You'd refer to this other name that you use to access it. Is that correct summary?
When you mean other name, you mean the
one that's not shown in the bucket request that you were just alluding to.
Yeah, yeah. So the name would be pointing not to this bucket, but it would be pointing to the bucket resource.
Yeah, the whole object.
Yeah.
So then technically, the only time you would actually have the bucket name exposed is through the information made available to the application.
Yes, the credentials. Yes. So yeah. So there is a tiny error here. I don't know if it's worth pointing out, but quickly I can show you. The name of the bucket is actually derived based on the bucket request and the namespace.
Okay.
Yeah.
Now, is namespace something that you can have more than one?
A bucket request, a single bucket request is confined to one namespace. If you have another namespace with a similar bucket request, then the name of the bucket that corresponds to would be different.
Okay, so we're restricting it that a bucket request can only be in the context of a single namespace.
Yes.
You would have to use a brownfield request if you wanted to share across two namespaces.
Yes.
And that would have. Go ahead, sorry.
Can you concatenate them with a dot, because it's like it's our typical. I mean, it would.
Can we have a dot in Kubernetes names? Wouldn't that make it more DNS style? I know, like in service names you can't have dots. So
that's I mean, I'm just saying it's a typical use case, and yes, you have dots in names. Because you'd have dots in URLs, so that's where.
Right. Okay, yeah, we can look into it. But I think the convention, sorry, do you mean in the name of the resource or do you mean in the name of the actual backend bucket?
I mean,
The actual bucket, I mean,
Oh, I see. Yeah, that's definitely
the
possible.
the metadata name, I mean.
Oh,
no, but the names are a thing. If you're concatenating namespace and name, you have to use a legal character, and that character as a separator, and that character could be in.
And dot is legal. That's
I
what I'm
don't.
saying.
I know what I'm saying, though, that it doesn't solve anything. If you're trying to be able to break apart the namespace from the name visually, any delimiter we pick, there is a case where that doesn't work. As
Yeah, if it's legal, yeah.
that's all I'm saying. The convention is to use dash in Kubernetes. At least that's what I see most often.
Yeah, same here. And as far as I know, dot is not legal in the names. I may be wrong.
Quick comment on the bucket resource object name. I think you're concatenating the bucket request name and namespace for that.
Yeah.
I think it may be worthwhile following the model for PV/PVC. I mentioned UID is not important in general. This is one place where it might be worthwhile to use the UID. That way you can differentiate between two different bucket requests. We may want to think through whether we want to do that. We did decide to do it for PV/PVC, and it might be worth figuring out if we want to follow the same model here or not.
So
Yeah, I think that requires a longer conversation.
Yep.
Yeah, we can note that down for now.
Yeah, it's good to capture the notes. Saad, we have this many-to-one mapping between BRs and bucket instances. Does that mapping there change your opinion any?
Off the top of my head, I'm not sure. I think I need to think more about it.
Okay. Is the UID something readily available to that persona that's going to be using it in this scenario, though?
The UID of the request should be available to the component that's going to be creating the bucket object. So
that's true.
Okay.
It's as readily available as the name.
Right. Okay.
All right. Right, going into bucket access class. The bucket access class groups a bunch of bucket access types. A provisioner field is set here to specify which provisioner understands this access class. Again, this has a set of parameters, a bunch of opaque parameters that are passed into the backend, and then policy actions. Policy actions define how this bucket is going to be accessed by anyone consuming using this bucket access class. In this case, I've written out a spec, an access control spec for AWS S3, where you can write and read. So put object and get object are allowed, and everything else is denied. So this is write once, read many times, which is write once, read many is the access control we wanted to provide for this bucket based on the example I explained. And yeah, this is an example that shows that. Any questions about this?
This policy action, is it going to be consumed by any other part of the Kubernetes system, or is it only for pass through to Cozy?
It is pass through.
So if it's only for pass through to Cozy,
should we make it an opaque string?
Yeah.
I'm actually, so again, we had a conversation about this, Jeff, I and Srini, yesterday. However, again, we wanted to make sure that when we bring about changes, we want to include everyone. I think that's a valid suggestion, and yeah, it's something we can add.
Yeah.
So that would be moving it into parameters?
Yes.
So it could be in parameters, or it could be called out, but just a single string, a JSON string, most likely, right?
The idea being that in general, if you have a field that is only consumed or is only passed through to the underlying driver, there's no need for us to make it a first-class field.
Yeah.
The only time we make it a first-class field is when a Kubernetes component needs to operate on it.
Yeah, that's good, Saad, thanks.
I agree, because the other effect that it would have is that the user may assume that it's validating these two against each other. Like, it's going to be up to the driver to make sure one of the allowed resources isn't on both the allowed and deny list. And we're not doing that with the actual cozy piece.
Yeah, that confusion could happen. Yeah.
Yeah.
So
Yeah, this becomes really important when you have multiple brownfield requests for the same bucket.
I'm actually kind of curious how this works with how this would work with the service account part.
Yeah. So the service account use case is where, I mean, the access policy would still look the same. It's just how the access is provisioned is what changes. What I mean by that is a set of credentials passed into the application, or is the application identity somehow known, or you know, any request coming from that application with that identity should somehow be given access. Like in AWS, you have instances having IAM roles, or you know, even pods having IAM roles.
The problem is that the identity you're mapped to on the server, you might map to that identity from several places. And so therefore, theoretically, from those different places, you could also all access the same brownfield bucket. And I'm trying to figure out if I'm talking myself into a hole here. So I guess, yeah. So this makes the assumption that a particular bucket access can be uniquely crafted at this point, and that if you therefore have multiple cases of that user trying to access that bucket, that's kind of its own problem. And I guess there's no way around that. And it doesn't matter that these policy actions, I don't think, make that problem worse.
But it doesn't solve it either. Like, you're saying that if I have granted service access, a role access to, I don't know, a particular object in one, and it happens to be the same name in the other, I'm going to automatically get access to it? What are you saying, Andrew?
So the original mechanism that was in the KEP was this idea that you would mint a new server-side user for every one of these. Mm-hmm. In that case, that implies that every bucket access can have a separately defined set of accesses. But in the case where you're doing a service account mapping, there is no longer a guarantee that every single access is uniquely minted. Right? It could be that, oh, the access is already defined there, or at least the user is already defined there. So I'm not minting a new user on the other end. So what it implies is that if I craft multiple cases, even different clusters, same cluster, whatever, where I'm asking for the same service account to have access to the same bucket, I can have conflicting permissions.
Yeah,
so
is that up to the provisioner, or do we put any restrictions on that?
Yeah, I don't see how, I mean,
the source
I don't see how we put a restriction on it.
Yeah, if you use the same one and it had more restrictive permissions on the second request or third request, you'd be locking out the first request.
Well, yeah, I mean, effectively the problem is the source of truth for the policy is not Kubernetes.
Well, it's the last affected policy, right? So if you keep dumping in new policies every time you create a new instance with the same service account, it's going to be last one wins.
Or you basically have a, you know, it already exists kind of thing, and then you leave it up to the driver to deal with that or something.
Yeah, I could see one driver trying to match to an existing, and another driver just saying, I will create a new user for each request.
I mean, the new user approach makes sense if you're doing the sort of credential minting. But if you're not using a credential minting, if you're using the GCP or Amazon approach of doing service account mapping, then the credentials are already known. The users on both sides are known. The only thing that you're minting is the particular access. But even then, if an access binding already exists for that user on that object, then I think the best thing to do is to just say there's already a binding for this user on this object. And because modifying it when it already exists seems to be fraught with danger.
Yeah.
So is this something that we need to go to SIG security with, Saad? Like, I feel like we're creating a hole of possibly accessing object data in buckets that we shouldn't be.
Well, no, it's just that we probably need to make the policy actions mutually exclusive with the use of a service account. Right?
Yeah. And it wouldn't hurt to get SIG auth to take a look at it, but yes, agreed.
But okay, so the policy actions are, unfortunately, as articulated, are these really generic? I mean, these look specific to S3.
And that's why we wanted to move it into parameters, because these are specific to the type, to the protocol.
And so I guess my point is, once you've done that, I don't know how you can, at the Kubernetes level, deconflict anything. You've just got to leave this up to the back end to handle it.
Yeah, each backend's going to provide in its documentation what parameters it can handle and what the semantics of those parameters are.
So just anyone doing an S3 COSI driver just needs to make sure to not permit both or something, right?
We're saying each COSI driver for each provider will be responsible for handling that collision.
Or only one service account.
And there will be only one service account, is that what you said? Sorry.
Yeah. What if we tied it to the service account instead of trying to understand the policy itself? That is, if a second bucket access class, we have a service account field in the bucket access class, and if a second request comes in for the same service account in a different bucket access class, we reject it.
So there's a couple of scenarios, right? So one of the possible scenarios is that I am crafting the complete access out of band, right? So I've got a service account on the cloud side that I've created. I've set up roles for that, so I've got all of my permissioning in place for that account to get to that object. Then I set up a workload identity or the equivalent AWS to map a Kubernetes service account to that. In which case, there is really nothing for a driver to do, potentially, right? One possibility is a driver could just say, it's already there. And I don't think you would necessarily want that to be an error. You might want to control whether it's an error, but that seems like a perfectly reasonable, because otherwise you're walking down the path of having to say, we want to construct every possible mode of access in the Kubernetes object, and I don't know how you deal with sharing in that case, because then you end up with conflicts expressed at the Kubernetes level.
And Andrew, what you said is actually an example of driverless. I mean, all this done on the back end, out of band, is you don't need the driver for that access.
Yeah, and so
driver is still a useful thing, right? So we don't want to make, I don't know.
Sure, I'm just suggesting a mode, and this gets back to the whole problem of sort of greenfield versus brownfield, right? In greenfield, you really want to automate all of it. You want to automate bucket creation. You want to automate, if necessary, service account minting. You want to automate credential minting. You want to automate passing the credentials into the client side, into the app. All of that stuff you may have to support kind of from scratch. And then there's various modes on top of that, like workload identity or the equivalent, where I'm not minting service accounts, but I may be minting just credentials. But then you could even say I'm not minting service account or credentials. I'm just, I have a mechanism here that says this is how I'm accessing it. And, but it's effectively a no-op because all of that access is already plumbed in. I just think we want to be able to support all of those. And I don't think it's too hard. It's just one of the things we got to do is to say something in a bucket access class or something that says, hey, I'm expecting this to have already been handled. Or override on, you know, or don't override, or, you know what I mean? Some kind of deconfliction policy statement at the class level, I think does it.
Yeah.
So you're saying if minting an account or a user or service account, then you would want to implement these policies. But if the account already exists, or if you're using a service account, that policy action should be ignored.
And further, you could even assert at the bucket class whether or not such an account must or must not exist on the other end, right?
Right.
That's a good point.
Yeah, that would work.
Yeah, I mean, I like the service accounts, but I also like the idea of being able to, set initial policy and have a service account and effectively kind of like an ARN role or whatever be minted for me. That corresponds to the policy, right? So that I can craft this bucket access class CR or whatever, and it, if it's minting something new, it creates the IAM role or whatever that's necessary that would be mapped in here. I'm not sure, maybe not. I don't know.
So we leave that to the driver then to identify if the access exists, ignore the policy action. If it doesn't exist and you're creating a new service account or a new user and credentials, follow the policy action as part of the bucket creation.
Right.
I think that's one option, which is to basically treat it as effectively a kind of idempotency kind of statement that says, look, I'm going to add this access, but if you've already got access, that's fine. But then the question becomes, how do you handle conflicts? Do you reject something whose policy actions don't match what you currently have? I mean, that's a possibility. And then if you don't provide these policy actions at all, then effectively you're making some statement about then, right? I mean, I think with just a little bit of fleshing out,
yeah,
we could come up with something reasonable here that isn't dangerous.
Well, and it shouldn't be dangerous, and it should be able to be solved consistently if you're trying to go to handle identity between two different ways that other clouds handle identity within.
Well,
I think it has to be done at the driver level, though.
I mean, it might be as simple as just if we're minting something new, then you can impart policy and you create a new IAM that only, like a new IAM user that only Kubernetes can, only this specific Kubernetes can use, and then basically that particular Kubernetes is the only one that's going to be able to update that policy object, and you could share that with you could also share that bucket with the application user that would be distinct from the IAM user for Kubernetes, right? And then if you have if it's an already existing and you're not minting a user or something, then you just don't allow policy updates at all.
We articulate these different usage patterns more so that we make sure we're not creating an issue, or do we not?
I think
I definitely that it's time to do that, and probably can't do it in the 8 minutes we've got here, but
yeah.
Oh, come on, 8 minutes is like.
yeah, I mean,
I think it's a fair suggestion, and I think we can figure it out in the future. But the issue is only when there are conflicts with two different bucket policies pointing to the same service account.
I think it's a little bit broader than that. And let me see if I can't articulate it.
Mm-hmm.
So, what I imagine is several levels of action you might take in response to a bucket class. Right? One action is, and I'm going to try to use generic terminology, and you know, hopefully it ports to the different platforms. So one action is I'm going to mint a user in response to this on the bucket side. Then I am going to add to that user permissioning to access this bucket. And I'm assuming, by the way, the bucket's already there. This is the bucket access. So I'm going to add a user, and I'm going to set permissions for that user. So that is a question of what I'm going to provision on the bucket side. I may also then mint some sort of access token or credentials for being that user in the context of an API call, because I need to do that, you know, coming from a client. So that's one area that I imagine.
Why isn't that just the provisioners? I mean, why does the cozy controller need to be aware of it? Isn't it just, you know, configuration parameters?
I'm sorry. I'm describing a scenario. I'm not saying who does it. I'm suggesting.
No, I understand.
Hey,
but
you know what?
maybe is it more than
1 second? I need to stop all of you. So we have like 5 minutes left. I think this is something we need to talk in a little more detail. We'll write this down for the next meeting.
I took notes on all of it.
Yeah. I want to finish this and, you know, come to a just get through this. To be honest, there's only like 2 or 3 slides left, and I think it'll paint a picture of what the response looks like, and then that'll give us more context. After you know, we go through and make this bucket access request call. So I'm going to quickly just go through this, and so that we have a picture of everything that's going on. So with this flawed model, okay, so you have the user and admin, request Cozy. Cozy goes ahead and creates a bucket access object, copies over fields, and then it goes ahead and calls the backend. Call this parameters again, bucket name. So here we have something called as a principal, which is what I wanted to introduce you to. So what we've thought of as the principal is the unique identity of who the new user is that gets access, or if it's an existing user that you want to update or provide new access to, you pass in the principal's unique ID. The access policy is the access policy we had earlier.
And that would assume that at this point the bucket already exists.
Yeah.
Okay.
So access policy is a direct copy of whatever is there in the bucket access class. Bucket context is, again, a copy of what's in the parameters and the name. We've set the principal empty in this case, and the response is creates a new user, gives that as the principal. So far, what we've thought is the credentials file contents and credentials file path will decide how this access is provided to the application. In case it's minted credentials, in case it's a service account, only the principal field should be set, and you know, the other 2 fields should be empty. That's about it. Yeah, that's about it.
So the driver specifies the path to the credentials?
Yeah, based on whoever the driver is, the credential resides at a certain default path.
Okay. And will there be some guidelines to make sure that a driver can't stomp over something else?
Guidelines, yeah.
Okay.
Yeah. All right, so I think we should write down things that we want to discuss for next week, specifically around bucket access class. And Jeff, did you want to take it forward now? We have like 3-4 minutes left.
Um,
Conclude.
It's another good set of suggestions. can we get a straw man vote on how people are feeling right now? We haven't done that yet. It would just be interesting. There's 16 participants on the call right now. In other words,
Yeah, I think this was a really productive meeting. I like the provisioning aspect of it. I think that's solid. It's looking good. From the access perspective, I think it's close, but we need to probably go through the flows for both a service account that already exists using workload identity and minting a new service account, walk through both of those flows just to make sure that they're handled properly. And then I think the third thing we need to walk through is the binding logic, because that's going to be crazy here because we're proposing something completely new, which is a many-to-one binding. So I want to make sure we review that as well.
And there's some additional gRPCs that we need to review.
Yep.
Yeah. I'll just echo that I think these review meetings are extremely productive, and we should keep going as long as people keep having questions. And I don't see any reason to hurry towards having it be done. I mean, if there is a reason, like a deadline we have in mind, and we want to go faster, like we should just schedule more time per week to do these kinds of meetings, 2 hours, 3 hours, whatever it takes. But we should take the time.
Completely agree with you on that. How do you all feel about joining us on our engineering meeting on Monday at 11 PST? I really want to go over this bucket class design. That would be a good time to do it.
You said 11 PST?
Yeah, it's the same Zoom link, isn't it?
Yeah, it is the same Zoom link, yes. It's a SIG storage.
You know, Ben, you mentioned urgency, and I agree. We want to get it right. I mean, there's no point in rushing and getting it wrong. But where I'm thinking is that if we get this PR merged, we can start using official repos, and we can get some prototype, you know, pre-alpha code out there and start using it. And I think when you have it in your hands and you're using it, you're trying to write a driver, things are going to come up that we may not just discover with this level of meeting.
That seems like a weird bit of administrivia where we're trying to merge the design just so we can write some code. Like that's backwards, and there's got to be another way to get code written before the design merges.
That's true. We can work on our own repositories with code. Yeah, I don't think we're really gated on having this merged before we can start writing code. But I think having it be more official would certainly not hurt us. Anyways, so I think the next step is really to nail the design of the bucket access types, and yeah, hopefully I'll see you all on Monday at 11. Jeff, do you think can we send an invite to everyone somehow?
I think if you update your calendar invite to include SIG storage, that'll do it. The SIG storage mailing list.
Okay. Sounds good.
Right.
All right. Thanks, folks.
Thank you all.
Bye.